In this video, we are going to continue our discussion of the method to solve a first-order linear ODE. So the first thing is, even though it says it's a first-order linear ODE, we got to get good at recognizing it because, like I said, on a test, I'm just going to say solve the DE. So dy dx, there's my y. Nothing weird is happening to those. They're not taking some power. They're not being square rooted or taken the square of or anything like that. No sign or anything. So as long as the numbers out front don't involve y's, we're good. Yeah. So the one out front, -3 and 6, those are okay things to have. If it had a y, then that would be a problem. If it had an x, we'd be okay still. All right. So first thing we need to identify is what is p of x. Well, p of x is equal to -3. So if I want to find mu, then mu of x, that is e to the integral of px dx. All right, so I plug that in. I got -3 dx. That tells me that the integrating factor is e to the -3x. Now, you may have asked to yourself, why don't we put a plus c there? The reason that we don't put a plus c is it works out in the wash. If you're unsure and you don't believe me, I would encourage you just to put a plus c up here and work it out and do it that way. And you'll see that it just ends up going in with another constant, so we don't actually have to worry about it. If you're curious about this, let me know. I could maybe make a video real quick of putting the c in there and showing you how it goes away. But for your integrating factor, you don't need it. Okay, so there's mu. So we made sure it's in the right form. It was. dy dx was by itself. It is a first order linear. And then we identified p of x, which was -3. Then we found mu by its definition. Mu is e to the -3x. So now I'm going to multiply the dE by mu. All right, so multiplying both sides by mu. All right, I got e to the -3x times dy dx minus 3e to the -3x times y. And then we get 6e to the -3x. Multiply everything by it. Okay, the whole point of this was this is now going to be a product rule between mu and y. You should check that. Okay, well, if I take the product rule and I take derivative of y, I get this. That's leaving the first one alone. The next one, I take the derivative of this one and leave y alone. Okay, y is left alone. As long as that's the derivative of e to the -3x, we're good. It is. So it does work out. You should identify that each time in your head. Right? The right-hand side, nothing happened. I didn't work anything out to get the product rule. I just identified that it was the product rule. The whole reason behind that is now, if I take the integral of both sides, all right, so I'm going to write that out. I take the integral of both sides, I can now do that, and the integral and the derivative actually cancel each other out. They're inverse operations. So I get e to the -3x times y equals, and then that's not bad. It's going to be a -2e to the -3x plus c. Here we want to see. All right, the reason how I do this so quickly without it's a u sub is I just write it down, e to the -3x, and then I think about if I took my derivative, okay, I would get a -3 that comes down times -2 gets me the +6. That's how I think about it because we do it so much in this class, and in Calc 3 we did a lot of integration as well. So you can skip that step. That's fine with me. All right, so this is implicit. If I wanted explicit, all I got to do is multiply by e to the 3x, positive e to the 3x. That cancels this. I got -2 plus c e to the 3x. We just multiplied both sides by that positive e to the 3x. So there is my explicit solution. It's a general solution. It wasn't an IVP, so we stopped there.